Hi, my name is Dr. Joe Roselle today, and today we're going to be discussing atmospheric water generators for episode 5. And the first question that somebody asked me is, can you really make water from thin air? And the answer is yes, with these atmospheric water generators. And there's actually more than one type. So today, the Wise Use podcast questions are, by implementing this technology, can we save money? And where do they actually make economic sense? And the answers to both questions might surprise you. So what is an atmospheric water generator? Well, it's basically a device that pulls moisture from the air, and it does it by causing a temperature differentiation. So there's a surface that's cold, and the cold surface causes moisture to condense on that surface, and then it's collected. And it produces clean drinking water. There's two different types of technologies for this. One is mechanical. This is something that has mechanical parts. It has a compressor. In this device, just like your car, your house, it creates a cold surface and the moisture condenses on that surface. For the passive version of these, they're just homemade devices, a box with a glass or a plexiglass surface and then a tube going down. It's the same type of idea where the temperature differentiation between the night and the day, as the sun comes up, it causes the box to heat up and it causes moisture to condense on that surface. But there is a huge difference in the amount the passive or non-mechanical device and the mechanical device. There's a huge amount of difference between how much moisture they can produce. So let's look at the homemade passive systems. A small do-it-yourself passive system without any mechanical parts can make about half a liter of water a day. A large version can make about 3 liters a day. And then if you live in areas like Chile or California, they use massive nets to collect moisture from fog. They can produce about 20 liters a day. So the problem with the fog collectors is they're really only applicable in areas that have consistent fog. So even the small and large systems don't really generate enough water for you to replace your drinking water. The average person drinks about 3 liters a day. So even the large system would only create enough drinking water for one person per day. That's it. Now, what about the commercial atmospheric water generators, the ones that have compressors in them? Well, they cost about $3,000. They produce about 10 gallons of water a day in optimal conditions. In a place like Arizona and Phoenix, where the relative humidity is only about 20 to 30%, they'll probably only create 5 gallons a day. So the big question then now is the atmospheric or commercial atmospheric water generators produce enough water. Does it make economic sense in all cases to go from your municipal water or bottled water to one of these atmospheric water generators? And the answer is it depends. So if you look at buying a machine, it'd be about $3,000, about $1,000 for electricity, $1,000 for maintenance. The total cost would be about $5,000. So over the course of 5 years of producing 10 gallons of water a day, 365 days a year, you're going to produce about 18,000 gallons of water. Now that equates to about 27 cents per gallon. How does that compare to other water sources? Well, when you look at municipal water, it's municipal water you can get on the high end for about two cents per gallon. So atmospheric water generators are much more expensive. Now, that doesn't mean there aren't applications for atmospheric water generators in cities, because there are over 22 million Americans that can't get safe drinking water where they are from their municipal source. So it still might make sense, if you can't get safe drinking water in your city, to use one of these atmospheric water generators, because it can replace your drinking water. But let's make a comparison to other sources of water you typically see in a city. I know a lot of businesses use 5 gallon water delivery because they don't want to use tap water. The 5 gallon water delivery at the high end is $3 per gallon. At the low end, $1.50 a gallon. So the atmospheric water generator, even for an office, would be significantly cheaper. Bottled bulk water, it's about $1 to $2.50, again, much cheaper. Now this is the shocking part, because we've talked about that convenience tax before. Convenience store bottled water ranges from $6 to $10. Again, much cheaper. So the key point when you're looking at an automatic water generator is, do you have a municipal source? Do you actually drink your municipal source? Because if you're purchasing bottled water, then the atmospheric water generator, even in a city that has cheap municipal water, is much, much cheaper. Let's look at some other scenarios other than municipal water where it's cheaper. And these will automatically make sense. And when you think of these, don't think about just the accessibility of the water, but the cost of transportation, fuel, labor to get water to these remote areas. So the first big one is emergency preparedness. So wildfires, floods, hurricanes, water outages, definitely cheaper to use these automatic water generators. Remote homes like cabins, ranches, off-grid homes, remote work sites, construction, mining, research stations. Again, this would be a good investment for all those applications. Another one where it's kind of it depends is marine applications. So if you have a desalinator on your boat, or if you have a way to purify lake water that's cheaper, it might not be cheaper, but if you live on an island and you don't have those applications, then it actually absolutely might be cheaper. So again, when you're thinking about what's the best application, just because you have municipal water doesn't mean you shouldn't get one of these if you don't drink it. It's using an atmospheric water generator for drinking water is much cheaper than bottled water applications. Now let's focus in on Arizona because this was kind of surprising, and every state differs, but approximately 11% of Arizona residents, about 850,000 people, live in remote areas that could benefit from this technology. Even though Arizona is a massive state, only about 89% of its population lives in 10% of the urban areas. 90% of Arizona's lands are rural, which includes tribal communities, ranches, campgrounds, fire lookout stations, construction projects, natural parks, scientific researches, etc. And all these are important considerations. So again, it's not just the cost of water. You have to think about delivery trucks, labor, fuel, plastic bottles, long supply chains, etc. But the other practical part you have to realize too, that when you think of an average household, you're going to be using about 200 gallons of water a day. So a typical atmospheric water generator is only going to make between 5 to 10. So what are the applications for it? Well, it's good for drinking water. It's good for cooking. It's good for coffee, but it's not good for showers, laundry, irrigation, because you just don't have that amount of water. You're not going to produce that amount of water. So the important question for you is, where is producing water on site cheaper, safer, or more practical than transporting it? And as we just discovered, there's a lot. So if you're going to try to decide, is an or atmospheric water generator the right choice for you, you really have to think about the following. So do an audit of your house or your business and think about, would producing water on site save money, reduce plastic, improve emergency preparedness, eliminate transportation costs? And if the answer is yes, an automatic water generator is right for you.